In this video, we're going to look at converting numbers from base 10 to any other base. And I'm just going to demonstrate the procedure using examples. So we're going straight into examples. First one says convert 24 to a number in base 2. So base 2, numbers in base 2. Basically, base 2 is the binary number system. I just put that there just so you know in case you come across the term. But the key thing is we're just converting a number, 24, in base 10. The subscript isn't shown. No, naturally you want to write 10 as a subscript, but because there's no subscript, you know that. Because there's no subscript, you know that 24 is a number in base 10 and we're required to convert to a number in base 2. So what's the procedure? Well, I'll just show you. So you have your number that you want to convert to a certain base, and then what we do is we repeatedly divide by the required base. The desired base is 2, and then we note down the remainders, and then the answer comes out from the technique. So watch. So this is the base we want to go to, and this is the number we are converting. So 2, the first thing asked yourself is 2, well, 24 divided by 2, that's 12, remainder 0. So we put remainders here. So I'll just put an R to remind you. Move on to this next number, 12, divided by the same 2. 12 divided by 2 is 6. What's the remainder? 0. Then again, 6 divided by 2, you get 3. What's the remainder? 0. Now 3 divided by 2, well, that's 1, remainder 1. So we continue. What about 1 divided by 2? Well, that's 0, remainder 1. And once you get a 0 here, you stop, and all you have to do is start from this bottom number. Basically, I'll just draw this arrow. Follow this arrow and write the number you see starting from the bottom. So it's 1, 1, 0, 0, 0. So therefore, 24 is equivalent to 1, 1, 0, 0, 0, base 2 in base 2. 1, 1, 0, 0, 0 in base 2. So what did I just do? We have the number 24. We're required to convert it to base 2. So what you do is you just divide the original number by the base you're going to. So divided by 2. You get 12. You note down the remainder. Then you divide this new number by 2. You get 6. You note down the remainder. And then you divide this new number by 2. You get 3. You note down the remainder. You divide this new number by 2. 3 divided by 2 is 1, remainder 1. So that's the remainder here. And then you note down, well, you divide this new number by 2 again. 1 divided by 2. That's 0, remainder 1. And once you arrive at a 0 here, you stop and you read off the number you have here, starting from the bottom in the direction of this arrow. So it's 1, 1, 0, 0, 0, 1, 1, 0, 0, 0 in the desired base, base 2. And that is all. So we're going to take another example. Here's another example. So we're required to convert 56 to a number in base 3, the ternary number system. So the key thing is we're converting a number in base 10 to a number in base 3. All we have to do is repeatedly divide the number we're converting by the desired base, and then note down remainders in the fashion that I'm going to describe. So 56 divided by 3, well, 3 and 5, 1, remainder 2, 3 and 26, that's 8. So 56 divided by 3 is 18, remainder 2. You can check it. 3 times 18 is 54, plus 2 is 56. So this primary school stuff, division of numbers and noting down remainders and quotients. So 18 divided by 3, well, that's simply 6 with no remainder. So that's a 0. Next, we divide 6 by 3, and that gives 2 with no remainder. And then divide 2 by 3, that's 0, remainder 2. So because we've arrived at a 0 here, we stop, and then just read off this number, which is in the desired base. So therefore, 56 is 2002 in base 3. And that's all. Here's a final example. So we are required to convert the number 866, which is a number in base 10, to a number in base 8, the octal number system. So we take the number we're converting and repeatedly divide it by the desired base whilst noting remainders till we get to a 0 here. So 866 divided by 8, that's 1, 0, and then 8 in 66 is 8, remainder 2. This is not a 0, so I divide by 8 again. 108 divided by 8, so that's, well, 1, and 8 in 28, that's 3, remainder 4. And then 13 divided by 8, that's 1, remainder 5. And then 1 divided by 8, that's 0, remainder 1. So we can stop and read off the number we've just obtained. And that just means that 866, which is a number in base 10, is equivalent to 1542 in base 8. And that's all. So this is it's very easy to convert from a number in a certain base to a number in base 10, and it's easy to convert from a number in base 10 to a number in any other base.